right, so we're going to look at section 8.2, which is law of cosines. So when we studied law of sines, we used it for solving three types of problems. Side angle, angle, angle side angle, and side side angle. So those three types fall under law of sines. Well, there's two other types, and those fall under law of cosines. Anybody think they know what the two other types are? Just by looking at the ones we've already used. Another way you can arrange those letters. Yeah?
Angle, angle, angle.
That wouldn't be possible to solve.
Oh, is it the side, side, side then?
So side, side, side would be one. I'm going to go back to angle, angle, angle though for a second. Because if I told you I have a triangle like it's equilateral,
you would never be able to find the side. Yeah.
You wouldn't be able to find the side. You'd know 60, 60, and 60, but you don't have scale. So no matter what kind of problem you're doing, you have to have at least one side. Sometimes two, sometimes all three, if you're doing side, side, side. And there's one other type besides side, side, side we're going to do today.
Side angle side.
Side angle side. Both side, side, side and side angle side, we run into a problem if we try to use law of cosines, law of sines. Because that might be your first question. Why don't we just use the same rule we've been using? You can't. Because the problem with law of sines is you need to know an angle, and you need to know what's across from it. Well, in side angle side, you don't have that. You have a side, but you don't know what's across from it. You have another side, but you don't know what's across from it. And then you have an angle, but you don't know the length of the side across from now. So you do not have, if you made a table, you don't have a full row. And that's the same problem with side, side, side. You have all the sides, but you don't know any of the angles across from any of the sides. So, what are we going to use? We're going to use a different formula, and that's the law of cosines. So on the test, it won't necessarily say use law of sines or use law of cosines. You have to know how to figure out, should I use law of sines or law of cosines? And I've listed the types for law of cosines, and there's the types for law of sines. Now, when you're doing side angle side, it always works. Side angle side is kind of like this one and this one. No matter what, you can solve it all the time, and you only have to look for one answer. This is the one that we really don't like for law of sines, because you can get the 0, 1, or 2 answers. And this one, it's not as bad as the one where you could get 0 or 2. You can get 0 or 1 solutions. It's actually very simple to figure out if it's going to work right away or it's not going to work right away. All you have to do when you look at the three sides, the rule for a triangle is any two sides added together have to be bigger than the third. So if I gave you numbers like this, do you think you could make a triangle out of those three lengths based on what I just said? No. Think about it. You'd have a really long side, and then a short side, and a little bit longer side. Well, those three sides would never come together to make a triangle. Any two sides added together have to be bigger than the third. That's the rule. So if you made, I don't know, if you made this more like, let's change this to like a 3 and a 4, I think that would work. 3 plus 2 is 5, 4 plus 2 is 6, 3 plus 4 is 7. Yeah, that would work. Okay, but any two sides added together have to be bigger than the third. Not equal, bigger. So that would not work. So that's how you check with side, side, side if it's going to work. Just quickly make sure any two sides added together are bigger than the third side. Is there a question?
You answered.
All right. So we're going to start with side, angle, side, and then we'll do a side, side, side. It would be helpful if I told you the law of cosines, so let's write that down. So it's going to start out looking like something you might already know. What's that? Yeah. That's the Pythagorean theorem, but we know the Pythagorean theorem only works on what kind of triangles? Yeah?
Right triangle.
A right triangle. So the law of cosines is basically the Pythagorean theorem with an adjustment. That's what the law of cosines is. And if we went through the proof of law of cosines, the way you prove it is the Pythagorean theorem. So what we have to put on the end of that is we have to subtract something. And this is what you subtract. Now, it's not really important what letters you use. It's more important that you see the pattern of the letters. Because you can write this starting with b squared. You can write it starting with a squared. You could write it starting with x, y, z, q, r, p, whatever letter you want to use. But it's the pattern of the three letters, not what they are. So the pattern is one letter squared equals the sum of the other two letters that you didn't use here, minus twice the product of the two letters you put right there, times the cosine of the angle across from the letter you started. That's the pattern. So let's see if we can write down the law of cosines if we started with a b or an a. Anybody think they could tell me what would go after the b squared? Yeah?
A squared plus c squared minus
Yep.
2ac times the cosine of beta.
Beta. Yep. Is that a different formula? No, it's the exact same formula. You're just writing it with different letters. Which is kind of pointless to rewrite the same formula 3 times with different letters. But, just to practice. How about if you started with a squared? Yeah?
A squared equals b squared plus c squared minus 2bc cosine alpha.
Yeah. So that's the pattern for law of cosines. Now, I've told you before, if you're doing a right triangle, you can still use law of sines and cosines on a right triangle. It's like using like a chainsaw to cut a piece of paper, though. It's a little overkill. You really don't need something like this to do right triangles. We have a simpler way to do it. But if you did use this on a right triangle, that means that this angle would be what? If you did it on a right triangle. It would be a 90. So we're not normally going to do this, but watch what happens if you try to use the law of cosines on a right triangle. You'd be filling in a 90 for the angle right there. And if you fill in a 90 for cosine, the cosine of 90 just gave me what? Yeah? 0. And what's 0 times something? 0. So what happens is if you try to use this on a right triangle, this entire part that I just put a box around becomes 0, and it's not there, and then it turns into the Pythagorean theorem. So essentially the Pythagorean theorem is this law without that part on the end because it's 0. If this angle isn't 90, then this will not come out to 0, and then it comes into play. Okay. Questions on the law of cosines? So there's really 2 ways we use this formula. You're either going to use this formula to figure out an angle, or you're going to use it to figure out a side. We're going to try it. Okay, so here's our first one. So it's exactly the same type of setup and same method that we did yesterday. We're going to start with a table. Now, how do we know looking at that table that this is or isn't a law of sines problem? Yep. And since we don't have a full row, that means it has to be law of cosines. The other way to think about it is to sketch it. Put A across from alpha. Put B across from beta. And then put C across from gamma. You probably could have told this just by looking at the table, but now I gave you the diagram. What kind of triangle is this in terms of the 5 types? Yeah. This is side angle between side, SAS. So that confirms what we just already knew. This is law of cosines. Okay. When you are solving a side angle side problem, you always have to find the missing side first. You have to. You have to find C. So we're going to set up the law of cosines. And we're going to look for a version of it that has an A, a B, and a gamma. We have to find one of the laws that has these 3 things in it. So which version has an A, a B, and a gamma? There's only one. Yeah? Yeah, the first one. Okay. We've got the A, we've got the B, we've got the A, we've got the B, and we've got the gamma. So we have everything that we need, and the C is what we're going to solve for. So we're going to fill in A and B into what's on the right. So let's write it down. You probably still have it in your notes on the same page. But if you don't, what I would do is on the test or on your reference sheet, just write down the laws so you can just look at them. Then you don't have to try to remember them. So C squared. And we can do some of it as we go, so it doesn't take as many steps. The next thing you need is A squared. What's A squared here? Yep. 16. Okay. What's B squared? Yeah. 49. Minus 2 times A times B. Well, 2 times 4 times 7. What's 2 times 4? 8 times 7.
56.
So 56 cosine 42. Okay, so there's your first step, doing a few of the calculations as we go. What's the next thing I can do there? Yeah.
Combine like terms.
Yep, combine like terms. What are your like terms there?
The 16, the 49, and the 56. Or you would add the 16 with the 49, you would subtract 56 from it, right? Or
so tell me what you're thinking if you had this here.
oh, never mind. Don't include 56.
Don't include the 56. The 56 is not a like term because the 56 is being multiplied by something. So you always would have to do that multiplication first before you subtract. Does that make sense?
Yeah.
So do the multiplication first. So we can do the 16 plus 49, that's fine. But then do the multiplication before you do the subtraction. What's 16 plus 49? Yeah.
65.
So 65 minus, and now we can type in 56 cosine 42. Okay, we're going to round this just like we have been. We'll go to 3 decimal places. 41.616. Now you can do the subtraction. So 65 minus 41.616. 23.384. Now that's not C, that's C squared. So what am I going to do to that to get C? Yep. Yep, take the square root. So we're using this number we've rounded, but we're going to 3 decimal places, so hopefully it should be accurate enough. Okay, so the length of side C is 4.836. All right, now we know side C. Yeah.
Could you just plug that all in the calculator, or would you rather us do it out?
Sometimes I don't trust the order of operations with the calculator because of the way it puts parentheses for certain things. So I tend to do it in several steps because sometimes when I plug in a huge thing in the calculator, it's easier for me to make a mistake. But if you feel confident you can do that all in one step on the calculator and you get that, then excellent. Okay, so let's write down what we just figured out. 4.836. And I'm going to put that in red to remember it was something we found. So when we started this problem, it was side angle side. Now we have more information. That 4.836 makes it another type now, in addition to side angle side. What other type is that triangle now? Yeah?
No, side angle.
It is a side-side angle problem. And it's also one more type. Yeah.
Side.
It is side, side, side. So now it falls under any of those 3 types. Well, those 2, if you think of it that way, you would continue with law of cosines. If you think of it this way, side, side angle falls back to law of sines. But side, side angle has an asterisk under it. Why did I put that asterisk there? Yeah?
Because it can have one solution, 2 solutions, no solution.
Right. If we think of it as side, side angle and do the law of sines, then we've got to go through all that reasoning of figuring out is the first answer right or is the second answer right? So we're going to stay away from using law of sines. We started the problem with law of cosines, and that's how we'll finish it. You could definitely use law of sines. You just have to be very careful because something could happen if you don't do it right. So stick with law of cosines, and you'll get the right answer, and you don't have to worry about any of that 2 solution stuff. Yep.
Will the problem ever ask us to do like a different thing? Like we started one way and we finished it like side angle?
It'll never ask you to.
But you can if you want to.
You can if you do it right. There's something you have to be very careful about, which I'm not going to get into. But it is possible. Technically, yeah. It's possible. All right, so let's finish it with law of cosines. So this was to find C. Once you know all your sides, you can find anything you want with law of cosines. It doesn't matter, because the key is you have all the sides. That's the important thing. Let's do alpha. So if we want to find alpha, just so I don't have to think of the formula and fill it in at the same time, can someone tell me what's the formula that has alpha in it? Chris?
A squared is equal to b squared plus c squared minus 2bc cosine alpha.
Yep. So now we're going to fill everything in we can and then simplify it. There's going to be a big difference here, though. When we filled everything in before, it pretty much had the letter already by itself the whole time, with the exception of taking the square root at the end. This time, the variable is not going to be by itself. We're going to have a lot of things with it that we need to move to the other side. Okay, we didn't move anything to the other side in the last problem. Everything was already on the side we wanted it. So it's going to be very different how we solve it. Okay, let's go through it. So a squared is how much? 16. B squared? 49. And how are we going to get c squared? I wouldn't take c and square it. Yeah.
Would you leave it as c squared and solve for that?
Do we even need to solve for c squared? Is that something we don't know at this point?
Just plug
Oh.
the value.
It's right there.
It's right there. C squared is 23.384. Don't take 4.836 and square it, because you just took the square root of that and you rounded it. Now you're going to take something you rounded, square it again, and then round it again. That's too much rounding. So just use the value you already had, 23.384. Minus, now I'm going to need a calculator for this, 2 times b times c. Well, 2 times b is 14. I need 14 times 4.836.
4.836.
What is it?
67.704.
67.704. Cosine alpha. Now, the first step starts out kind of the same. We can combine like terms. What are my like terms there? Yeah.
49 and 23.384.
Yes. 49. 49 plus 23.384. So that adds up to 66.384. Minus 67,704. Now, this is where some people make a mistake. And the way I would think of it is, if you're confused what the next step is, think of this cosine alpha. It's just something you don't know. Just a variable. So think of this problem like this. Don't write this down. But that's basically the equation you're trying to solve right now. And I just rounded everything off. If you were trying to solve this for x, what would be your next step in this bottom equation? Yeah?
Just subtract the 66 from this side.
Right, you need to bring the 66 to the other side. You can't do 66 minus 67, because those aren't like terms. Tried to kind of explain that before too. So bring the 66 to the other side. So minus 66. That's gone. And it's okay to do out 16 minus 66.384, because it's not an operation that's going to give me even more decimals and I have to round it. When I do this, I'm going to get 3 decimals, and I'm not going to round the answer. I'm just going to write down exactly what it tells me. So 16 minus 66.384. Okay, so there's my 3 decimals. Negative 50.384. Negative 67,704. Okay, so now I have 2 things left to get rid of next to alpha. The negative 67 and the cosine. What would I do next? Yep.
Both sides of
Yep. Divide both sides by negative 67,704. That's going to cancel the negatives and the 67. And that's going to cancel the negatives on the other side. Now, at this step, I would not do this out. Bless you. The reason I would do this calculation out was because you're probably going to get an answer that has more than 3 decimals in it when you do this division. If you round it again, it's going to be rounded a little bit. So just leave that the way it is. Okay, don't even bother doing it out. Okay, so now we have equal to cosine alpha. At this step, you should check something in your equation. You should make sure that the number in the bottom here is bigger than what's in the top. It has to be. Okay, we'll see why next. Yeah.
After you get 66,
Yeah.
23,
66 point.
yeah, you got 49 to 23.384, it should be 72.
Yeah, that's what I got. 72.84.
It looks like on your calculator you put in 43.
Oh, I put in 43. That's not good. So that should have been a 49 plus 23.384. Yeah, I can't even blame somebody else for that. I'd like to, but I can't. That was my fault. I'm sorry. I let you down. 72.384. So the 66 right here. That should be a 72. Which means you would have then subtracted a 72. Which means that's still gone, but now I need to do 72. So 16 minus 72.384. 72.384. So that gives me negative 56 instead of negative 50. Because the number I typed in was 6 off. So that's a negative 56. Now I think everything else is okay. Okay, so now at this step, we need to make sure that the number in the bottom is bigger, and it still is, so that's good. Because I want to get rid of cosine now. How do we get rid of cosine? We're going to take the inverse cosine. When you take the inverse, actually it doesn't matter, sine or cosine or something. The number that you fill in has to be between two values. When you take inverse sine or cosine, you can only do it if the number is between what? Yep. 1 and negative 1. The only way a fraction can be under 1 is if the number in the bottom is bigger. If you put a bigger number in the top of a fraction than the bottom, like this, if a bigger number is in the top, when you divide it, you don't get something less than 1. So that's why I always look at this step and make sure that the bigger number is in the bottom. If it's not, you might as well just stop and go back because something's messed up. This kind of problem always has a solution. So if it doesn't, you did something wrong. So inverse cosine of 56.384 divided by 67,704. So that gives me an angle of 33.613, assuming I didn't make any other mistakes. 33.613. Well, now we've got 5 out of 6 pieces of information, and 3 of those are sides. So how can we get the last angle? Pretty simple, isn't it?
Add the 30, the one we just found, to 42 and subtract 180.
Yeah, so now just add the 2 that we have and subtract from 180. Yes. I'm having a rough day. So 180 minus 33.613 plus 42. Okay, so that makes the third angle 104.387. So in a side angle side problem, you always have to do law of cosines twice. Once to find a side, once to find an angle. Always. That's how you do it. Yep.
Why don't you get 2 answers?
Why don't we get 2 answers? Well, think about if you knew this, right, and you draw it. I'm just going to try to reason it through. I don't really know a mathematical way to prove what you just said off the top of my head. But if you have that information, I wish I had a spot to put it. Right there. And you say, well, I want to try to draw 2 different triangles out of that information. The problem is you were given 2 of the sides. The only option you have here is to connect this point to this point. I mean, do you have another way you think you could make a triangle other than what I just said? No. You have to connect this to that to make the third side. And it's going to result in this angle and this angle always being the same, and that angle and that angle. There is no other way to assemble those pieces to make a third triangle, a second triangle. Now, with side-side angle, that's different. You can. But you can't put that together. If the red stuff has to stay exactly the way it is, you don't have much flexibility about what you draw left. You pretty much just have to fill in the third side. Yeah.
Is that why if we tried to do side-side angle, it would have complicated it?
Yeah, it can lead to being more complicated than it needs to be. Yeah. That's why if I start with law of cosines, I just finish the problem that way. So this problem is a good problem for law of cosines because it reviews everything that can happen. Finding a side, finding an angle. This problem, you're never finding sides. All you have to do here is find an angle. Now, at a minimum, you're going to have to do law of cosines how many times? Yeah, twice. You can do it twice at a minimum. You can find this using A, B, and C. Then you can find this using A, B, and C. The nice thing about side, side, side is if you wanted, and you really find this kind of fun, I mean, it's pretty fun, I know. You could find this using law of cosines a third time, and you'd be finding all three of these things totally separate from each other, which means if you make a mistake on one, it would not mess up anything else. This is the only kind of problem we've talked about that you can do that with. You do not have to use anything that you find to find something else. All the other types you do. But to save time, what I'm going to do is I will do law of cosines twice, and then I'll add it up and subtract from 180. Okay, it saves time, but if I made a mistake, it's going to make the third one wrong automatically. Not that I ever make a mistake or plug anything in wrong, but I'm just, So, doesn't matter which two angles you find, right? You know all the sides. So you could do alpha, you could do gamma, right? Or beta and alpha. You pick any two you want.
Would the safest method be to do each one individually and then add up the angles at the end to see if they all equal 180?
Yeah, that would be better. It's going to take longer, but then if you do each one separate and they all add up to 180, then you probably are guaranteed you did it the right way. So let's start with which version haven't we used yet? We started with C. We started with A. Let's start with B. So B squared, A squared, C squared, 2AC, cosine beta. Okay. As long as the sides are all integers, the numbers actually are a lot easier in this kind of problem. What's B squared?
49.
A squared?
81.
C squared?
29.
25. And 2 times A times C. Well, let's do it like this. Let's do 2 times C times A. What's 2 times 5? 10 times 9. 90. So that's 90 cosine beta. Okay, combine like terms. What's 81 plus 25? 106. Okay. Now I got 3 things I need to get from the right side over to the left. What would I do first? Okay.
Subtract 106 from each side.
Subtract 106. And this is okay to type in because we're not rounding anything. So I might as well type it in and just get the answer. Negative 57. Negative 90. Okay, what would I do next? Yeah.
Divide each side by negative 90.
Okay. Divide by negative 90. That's going to cancel that, and that. And the bigger number is in the bottom, which it always needs to be for the next step. Don't write this out, though. 57 over 90 is probably not a nice decimal. So we're just going to leave that. And what would be my last step?
Take the inverse cosine.
Take the inverse cosine. Alright, let's see what we got. So inverse cosine of 57 divided by 90. 50.704. That's beta. That's a 4. And now you just do the exact same thing one more time. The only difference is instead of starting with b squared, start with a squared or c squared. It's going to be all the same numbers. They're just going to move to different spots. So is there any question how you would do law? Basically do this step one more time, but don't start with b squared. All right, so let's finish up, at least set up our diagram for our last problem. So in this case, we have a surveyor that wants to measure the distance between 2 points, and maybe they're on opposite sides of a canyon or something, so it's just not easy to do it directly. But for whatever reason, they need to figure it out with trade. So points A and B, in this case, are just going to be on opposite sides of the building. So they're going to give us a diagram that kind of sets up what's happening. So it says we're going to have a building at point C, and the surveyor is basically going to measure the distance from where they're standing to 2 points on each side of the building. So let's say I wanted to find the distance across the back of the classroom. What I would do if I was using this method is measure the distance from where I'm standing to the file cabinets, and then from where I'm standing over to the calculators. Those are the two distances I know. And the third distance is going to be the side of the triangle that would be along the back wall. Okay, so surveyor is standing at point C. Let me show you the picture. So here's the surveyor. He's standing right there. He measures the distance from where he's standing to point A and where he's standing to point B. And measures the angle between those 2 points to be 54 degrees. So there's the diagram. The question is to find the distance between the 2 points. And in this case, it would probably be easy. You could just measure it. But again, maybe there's a river or something and you can't go across it easily. I mean, another reason why maybe he can't just measure the distance directly between the two houses is there's a genie between the two houses. And the genie is known to be very dangerous. So he gives you the opposite of what you ask for sometimes. So you don't know if you should ask for what you want or the opposite of what you want. It gets confusing. So he confuses you. That's what he does. So we don't want to try to measure this directly. So we're going to be safe and we're going to use trig. Trig saves. Right? Use trig. All right. So first of all, what kind of triangle is that? Yeah.
Side angle side.
It is side angle side. And the goal is to basically figure out, I'm not going to call it A, B, or C because I've already used those letters. Find X. If you're trying to find a side you don't know, that's what you start with in your formula. So I'm going to start you off with this. What do you think would come next if we're going to do law of cosines with these numbers. We started you off with the side you don't know.
160 squared plus 110 squared.
160 squared, yep. Plus the other side squared. Okay.
And then there's 2 times 110 times 160
2 times the product of the sides that you just put right there,
times the cosine of 54.
times the cosine across from the side that you started with, which is 54. So as far as the word problem, now you've basically taken the word problem and you've gotten rid of all the information, and now you've reduced it to just an equation like we did at the beginning. So you're going to have to take the square root at the very end. If you want to try to type that in one step, you can, but you might make a mistake. So we can go over that. If anyone has a question on how to solve it, we can do one side angle side and side 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 tomorrow when we go over the homework. Questions on that? So lesson was a little bit shorter because I think we spent about 40 minutes on the homework, but that's okay. I am going to adjust that slightly. So 1, 2, 5, 6, that's okay. $19 is okay. Let's do this. Okay, so 1, 2, 5, 6, and 19.